Okay, so this is a linear regression question. We've got the table given to us here. First of all, we need to input that data onto our table. So we look in stats and edit, and you can see I've already written T as list 1 and S as list 2. Right, so the next thing we need to do, let's just quit that. In the statistics menu, we need to calculate the linear regression, and we need to tell the calculator we're looking at list 1, comma, and also list 2. And what I like to do here is comma, if you go variables, y variables in here, you could tell it to put that linear regression line into y1. Okay, so here's our line of regression. We can write that. I need a pen.
Okay, and we want to take three significant figures for this. So y equals 3.56 x minus 14.6. All right.
Nice.
So, and that is relating s on t. So s is dependent on t. The ice cream scales are dependent on the temperature. So y is the ice cream sales and x is t for time. Okay, it says write down the equation s on t. So we should use s and t. Might take away 1 point there if we leave it in x and y. Good. And next we're asked to use your equation to predict the ice cream sales on a time when the maximum temperature, so temperature is the independent variable, of 24. And since Mr. Cole here, he had a good example of putting it into y equals already. All that equation is sitting there, so giving your answer, he can just calculate the value.
Okay, so we look at the graph, and then, where are we? Second, calculate the value. Okay, when x is 24. Oops.
Okay, so adjust your window to make sure that your calculator has the value in the window. So
if I go if I go zoom stats, because we put in all those points, that's gonna be quite nice. Oh, I thought it would be quite nice.
So window, and since temperatures of negative temperatures make sense, but our maximum temperature is indicates probably we should have a maximum of what, 35, 40?
There you go, 40.
Okay, and these numbers need to be much higher. Ice cream sales upwards of 100.
So we're getting those to 0 up to 120.
Okay, so change that y max to 120, not y scale. And at this point we're doing something called interpolation. Okay, because 24 is a temperature that is within our given range. So the calculator didn't like it before because 24 wasn't visible to it. So we just showed you that as an example of how it's important to do the window, right, Mr. Cole?
Absolutely. Okay, so now we can see it. It's here. It's in the middle of the data that we drew, and the y value, or is S?
S, the number of ice cream sales.
Number of ice creams to the nearest whole number is 71. So 71
Good.
ice creams.
Now both of these are worth 3 points. What you can do for method marks in the second part is you can draw a sketch and clearly indicate on that sketch what you've done, labeling that point. Or if you're a little bit more traditional in your approach, what you can do is simply put the t value of 24 into the algebraic equation that you generated, the regression line, and solve it. So equals 3.56 times 24 minus 14.6. Takes a little bit longer, but for some of you, you might be quicker at that. Either way, I think if you take Mr. Cole's advice and you put the regression line straight into y1, then you will easily save yourself time for these 6 marks. You can do it nice and quick like that. Good?